Hello, class. Welcome back to this amazing session. So, this is the lecture number 3 of this lecture series on set theory, which we had started last time. Okay. So, in the previous class, we had started what are the different types of representation of sets. Okay. How do we represent sets in two different forms? Okay. So, one is roster form, other is set builder form. Is that clear? Very good. So, let us take one more example to understand it better. Okay. Suppose I define a set A contains X such that X is an integer. X is an integer and X is greater or equal to -3 but less than 7. Okay. So I have defined a set A which contains X. So this set has X. Now I'm defining what this X is. This X is an integer and X is from -3 to 7, but -3 is included. Got it? So this set is represented in set builder form or in rule method form. You can see I am not mentioning the elements. I'm not writing the elements. I'm just writing the rule. Got it? That's why it's called set builder form. Now, the same set I will write in roster form or tabular form. So set A contains what? -3 because it starts with -3. You can see from here. It started with -3 because X is less or equal to -3. So -3, -2, -1, 0, 1, 2, 3, 4, 5, 6. Up to 6 only. Got it? So set A both in roster form and tabular form. Got it? Any confusion in this? Okay. Please understand one more important thing here, how to understand this interval. X is less or equal to -3. So -3 is included in this set, but less than 7. 7 is not included. It's only up to 6. Understood? So this is called roster form and set builder form. Okay. Let us take one more example. Let me rub the board. Okay. Suppose set A is 3, 6, 9, 12, 15. This is set A. And I have written this set A in roster form or tabular form. Got it? Now, can you write this set in the set builder form or in the rule method form? Yeah, we have to define some rule which will represent all these elements. So, I'll write, we'll say set A contains X such that, now define this X. What is this X? What is this X? You can see 3, 6, 9, 12, 15. These are all multiples of 3, but up to fifth multiple only. Up to fifth multiple only. So such that X equals to 3n. What is 3n? 3n means multiples of 3. And what is this n? N belongs to set of natural numbers. And n is less than 6. Understood? So X is multiple of 3, but up to 5 only. up to 5. That's why I have written n is less than 6. So it will go from 1, 2, 3, 4, 5 up to 5 only. The values of n. If you will put value of n as 1, you will get x as 3 ones are 3. See, 3 ones are 3. If you put the value of n as 2, 3 twos are 6. If you put the value of n 3, 3 threes are 9. If you put the value of n as 4, 3 fours are 12. If you put the value of n as 5, 3 into 5 is 15. Got it? So we got all the elements 3, 6, 9, 12, 15. Understood? So we have done this question and we have understood how can we represent a set in set builder form and in the tabular form or in the roster form. Okay. So in this way, we completed this representation of sets. Now let us focus on new thing, that's types of sets. Although I have covered some parts of it in my first lecture, but something is remaining. So we'll try to cover that in this session. Types of sets. Okay. First of all, I had told you what is void set or null set or empty set. EMPTY. Empty set. A set which contains no element is called void set, null set, or an empty set. It is represented by the symbol phi or these empty curly braces. You will ask, sir, if it what is the set which has no elements? Yeah, we can define sometimes we can define a set which has no element. Suppose I will ask you, set A is a set which has all natural numbers less than 1. So it's an empty set. It is an empty set because there is no natural number less than 1. Got it? So it's an empty set. Got it? Second classification is second type of set is equal sets. Equal sets. Suppose if set A and set B are equal, it is represented with this A equals to B. Set A and set B are equal only and only if all the elements of A are in set B and if all the elements of set B are in set A. Got it? Means if the elements of A and B are identical, same, they are called equal sets. Suppose set A contains 1, 2, 3, 4. And set B contains 4, 1, 2, 3. So you can see all the elements are identical. The order does not matter in case of sets, okay? The order, you can change the order of the elements. That will not change the set. So set A and set B are equal. Got it? Because they have same elements. Next important thing that we have to learn is subset. Very, very important. Subset. Subset. What is a subset? It is represented with this symbol. Suppose set A is a subset of B. What does that mean? It means every element of set A is contained in set B. Suppose if I define set B like this, set B is 3, 6, 9, 12, 15, 18. This is set B. And set A is 9 and 12. Now can you see? Set A is part of set B. Set A is contained in set A is contained in set B. Set A is a small part of set B. So we can say set A is a subset of set B. Got it? Suppose if I define set C like this, 20 and 20 comma 21. Set C does not belong, is not a subset of B. Set C is not a subset of set B. I hope you understood it. So what are the subsets? If a set is a part of another set, we can say first set is a subset of second set. In this case, we saw how the set A is contained in set B. So set A is a part of set B. So we can say set A is a subset of set B. Got it? Now, very interesting thing. If A is subset of B, B is also subset of A. It is only and only and it is only and only possible if A equals to B. This symbol means if and only if. If A is subset of B, B is also subset of A. This is only possible if the two sets are equal. Got it? So this was about the subsets. I hope this is clear to everyone. Now we will understand one important terminology very often used in this set theory, that's intervals. Intervals. A, B, closed in square brackets. This is called closed intervals. This simply means all the elements from A to B, A and B included. Example, -2 and +8. So this is a closed interval. What does this mean? -2 and 8 inside the square brackets. It means all the real numbers from -2 to +8 on the number line are included in this set. Suppose I draw a number line here. This is a number line. So as you know, center of number line is 0. Here it is 1, 2, 3, 4, 5, 6, 7, 8, and so on. Okay. Like here also -1, -2, -3, -4, -5, and so on. Now, what does this closed interval means? From -2 to +8. So if it is closed interval, we have to show with a solid dot up to +8. +8 is also included. So all the real numbers from -2 to +8 are included in this set. This is called closed interval. There are millions of real numbers from -2 to +8. Real numbers. But if I talk about integers, how many integers are from -2 to +8? So they are -2, -1, 0, 1, 2, 3, 4, 5, 6, 7, 8. These are only the integers. Those are included in this interval. But if we talk about real numbers, there are millions, because between 0 and 1 we have infinite real numbers. Between 0 and 1 we have infinite real numbers like 0 0.1, 0 0.01, 0 0.0001. Okay, so I can write millions of real numbers between 0 and 1. We can call them also decimal numbers or rational numbers, or in short we can call them real numbers. But between 0 and 1 there is no integer. Integer is 0. Integer is 0. After 0 it is directly 1. Between 0 and 1 there is no integer. Same is case between 1 and 2. Between 1 and 2 there are no integers. 1 is integer. After that 2 is the integer. But between 1 and 2 there are infinite real numbers. Got it? Same is true with natural numbers. 1 is natural number. After 1 it's directly 2. But between 1 and 2 there are no natural numbers. No whole numbers. No integers. Hope this is clear to everyone. Got it? So this is called closed interval. Now, if I write like this, minus 2, 8. You can see they are inside the brackets, but they are not square brackets. It's called open interval. This was closed interval, and this is open interval. It simply means all the real numbers between minus 2 and 8, but minus 2 is excluded, 8 is also excluded. How do we show it with a line? Like this. On minus 2, you have to show a hollow dot because minus 2 is not included. Up to positive 8. Also here, draw a hollow sphere, hollow circle, because 8 is not included. So this is called open interval. Got it? Now, if I say minus 2, comma 8, now you can see on the side of minus 2, it's square bracket. So minus 2 is included. In this case, minus 2 is included. So it should be a solid circle or a filled circle on the minus 2. Got it? So, or it may be like this. Now, 8 is included. 2 is excluded. But 8 is included. Okay? So this is how we represent intervals. Okay. This is also very helpful when we have to represent numbers from a certain number to the other number, or we have to show a range of real numbers when representing numbers in case of sets. Got it? Okay. So this was all about intervals. We did some questions on the representation also. We understood some types of sets. In the next class, hopefully, we will understand a very, very interesting topic which is called universal set. Universal set. Okay. Then we will understand Venn diagrams and we will solve some questions, story problems, word problems, or the real life problems which are solved with the help of Venn diagrams and operations on the sets. Okay. So till then, take care. Bye bye. Thank you.